Check. Madam,
Yes, sir.
we'll start exactly at 3 o'clock.
Okay, fine.
Good afternoon, all. I welcome you all for today's afternoon session. In afternoon session, we have two sessions, each of 1 hour. So our today's first speaker, I'm going to introduce briefly. Dr. Mrs. Rajashree English Badage is presently working as a Dean of Industry Institute Interaction Cell at SKN Sinhagad College of Engineering, Pundarpur. She has been worked as training and placement officer for more than 3 years and headed MBA department for more than 5 years. She also served an industry for more than 2 years as a human resource manager at Bharat Forge Pune and relationship manager at ICICI Bank Limited. She has more than 10 years of research experience and her interested research area is human resource management and rural development. In this context, she has presented more than 25 research papers in national and international conferences and published the same. She also has published a book named Human Resource Development Practices for Rural Development. She is actively working as a co-editor for National Peer-Reviewed and UGC-approved journal named Indian Journal of Research in Management, Business and Social Sciences. Also, working as a co-editor for International Journal of Advanced Computer Technology and Management, is a tri-monthly peer-reviewed online open access international journal published by Show India Institute of Management and Technology, Ghana. So this is the brief introduction of our first speaker. Now, I would like to request Dr. Rajashree ma'am to start her session. Thank you.
Yes, sir. Thank you so much for your introduction. A very good afternoon to all. Yes. Okay, fine. So my today's topic is hypothesis testing. Basically, whenever we are entering into research, we have a phobia of this word, hypothesis. In my today's session, I'll definitely try to overcome this phobia, this afraidness of the researchers, new researchers, and I hope you will enjoy this session. Let me share my screen with you. Just a second. I hope the screen is visible to you, all of you.
Yes, visible.
Yeah. So let us go ahead. I first of all very much thankful to the General Science Department of SN Sinhagad College of Engineering, Koti Pandharpur. Thank you so much for giving me this opportunity to present myself in front of the research scholars. Okay, so let us begin. As I said, whenever we are talking about hypothesis testing, it's means what we understand out of it, that it is concerned with the statistics. And if you wish to go for hypothesis testing, we are generally searching for the statistician. So I feel so, students, there is no need to go for the statisticians. You should yourself can check, can test your data, your hypothesis yourself. And in this session, I'll make it so easy for you, and I'll make you understand all the basic concepts which are concerned with the hypothesis. Okay. So what hypothesis means generally, these things we are going to cover in this session, particular session. If time permits, I'll go in detail with the test statistics. Let's see how it will be happen. Okay, so let us begin with the hypothesis meaning. As we all know, hypothesis is a kind of assumption we are making regarding our study, right? So these are what some formal definitions here for you. See, hypothesis offer a solution. Just a second. Let me. Oh. Just a second. I'm just searching for the. Okay. Pane is not visible here. Oh. Okay, fine. Let it be. Fine. So this is what the outline. First of all, we are going to understand the meaning, and then we are looking meaning and types, and then we are looking for how we are developing a good hypothesis, and then we will check some terminologies which we are using in the hypothesis testing, and then we will go with the procedure, actual procedure, what we are following while going for the hypothesis testing, and then we will go with the statistics. Yes. So as we all know, what is the meaning of hypothesis? Hypothesis is basically the assumption which we are making towards our study. Whatever study we have decided, whatever problem we have decided for our research, we are just making some assumption for the solution of that particular problem, right? So here, this is what the formal definition. Hypothesis offers a solution of the problem that is to be verified empirically and based on some rationale. This is what important for us. Empirically we are, means these hypotheses must be empirical, means they must have some proofs and it must be tested. Okay, so we cannot just go with the assumption, whatever we are just thinking, that we cannot write as a hypothesis. For that we have to think about the population first of all, which population we are going to study in our particular research, that we need to consider first. And then we have to think about the variables, what kind of variables we are using for our study. And then we are going with the relationship between these variables. Means we are finding out some relationship between these variables, and on the basis of these relationship between variables, we are forming a statement, and that statement is called as hypothesis, right? Okay. Now, as we are saying here, variables is an important part, very important rather, while forming the hypothesis. Okay, so there are basically two types of variables. First is dependent and second is independent, right? So the dependent variables is something which the researcher can observe and measure, right? And the independent variable is something that researcher can change or control. So independent variable is in hands of researcher. He can change or she can change or control that particular variable, but dependent variable is depend on the independent variable. Look at the example, you will understand. Independent variable. Here I have taken this example and two variables I have taken over here. That is, the first variable is biofertilizer, right? That is X, biofertilizer X, and the second variable is plant growth. Two variables are there. Now see, what is the independent variable over here? That application of fertilizer X in this experiment, application of biofertilizer. Now how it will be affected? It will be affected on the plant's growth. If we apply biofertilizer X, then definitely plant growth will be there. And this is what my assumption. This is assumption, but along with this assumption, I'm using these two different variables, whereas biofertilizer is my independent variable. Why it is independent variable? Because it is a cause, right? Just because of use of fertilizer, plant growth is possible, and that's why plant growth is what? Dependent variable. If I change my independent variable, dependent variable may get changed, right? Okay, look at the another example. Daily apple consumption lead to fewer doctors visit. Here, what is the independent variable now? Apple consumption, right? And that is what the cause. See here, you can understand the dependent and independent variable in the sense of cause and effect. So generally, independent variables are causes, whereas dependent variables are effects, right? So what is the dependent variable here? Frequency of doctor visit. That is what? Effect, right? Likewise, you need to remember the variables in the hypothesis. Yes. Now types of hypothesis. Basically, there are two types of hypothesis. You might know that, you might study during your academics, during your education. But now, whenever we are entering into research, actual research, it is more most important to understand the null hypothesis and alternative hypothesis, because null hypothesis we are going to test in our research, and that's why it is very important to understand first of all what exactly the null hypothesis and what is the alternative hypothesis, right? So null hypothesis is a statement, as you know, null means what? No or not. So here, yes, exactly, we are taking the same meaning of null over here, but in regards of association or relation between the groups or between the variables, we are considering this null hypothesis. So the null hypothesis is a general statement that states that there is no relationship between two phenomena under consideration, or that there is no association between the two groups. So here we are considering two groups or two variables, as we said. Now, what we are saying here, whenever we are formulating the null hypothesis, we are stating that there is no relationship between these two variables. Okay. And what is the alternative hypothesis then? Alternative hypothesis is totally opposite to the null hypothesis. It indicates that there is a definitely a relationship between two selected variables in our study. That's it. Look at the example, you will understand. Here, okay, one more thing I need to tell you that null hypothesis we are denoting by H naught. Please remember this sign, H naught. And alternative hypothesis we are denoting either by H1 or HA. Okay. So you can either use H1 or HA. No issue. Fine. Look at the example, you will understand. Here, again, the same example I have taken here to make you understand the alternative and null hypothesis. Now, what we are saying, no relationship. Null ka meaning hota hai no. So, whenever we are finding out the null hypothesis or stating out the null hypothesis, then we can say in this example that application biofertilizer X do not increase plant growth. Variables kya hai apne? What are the variables? That use of or application of biofertilizer X and plant growth. These two variables are there. If there is no relation between these two things, then it will be considered as a null hypothesis, right? And if there is a relationship between use of biofertilizer and increase of plant growth, then yes, of course, there is a relationship, and that is what called alternative hypothesis. Please do remember. Okay. Now let us see how we can develop a good hypothesis. Before looking at this, or before going to develop a good hypothesis, you must remember that your hypothesis must explain what you expect to happen. Means what you are thinking actually about your research, about your problem, or whatever assumption you are making about your research study. Your hypothesis must be very clear and understandable. It must be testable. This is really important for us. It must be measurable, and it must contain an independent and dependent variable. That is what important for us. So here you can understand, first of all, you need to identify the variables, right? Okay, so now step by step, let us see how we can develop a good hypothesis. First of all, you need to ask a question. You need to ask a question. Question here means what? This is your research question. What research question or what? See, whenever you are starting for a research, you have something in the mind that you are searching a answer for that question, right? So हम लोग ऐसे तो study नहीं करते, ऐसे तो research नहीं करते. Something is there behind that, and that is a question, and you are just searching answer for your question in research, right? And for that you are collecting then facts, figures, then you are studying too many things, means you are going with the conceptual framework, this and that, right? So first of all, focus on your question. The question should be focused, specific and researchable within the constraint of your project, right? तो जो आपको question, whatever question you are going to define, that must be researchable, that must be specific, focused, okay? For example, do students who attend more lectures get better exam result? This is what a question rise in my mind. Do students who attend more lectures get better exam result? Okay, if now this is my research question, how can I go ahead with this? For that, the second thing, I need to go for some preliminary research. Just getting an idea of this question. See, I'm just blinking this idea in my mind that attendance or exam result का कुछ relation है क्या? अगर है तो क्या? So for that, what I need to do? I have to go with some preliminary research. For that, what I need to do? I have to go for some theories and previous studies. पहले ऐसा किसी ने study किया है क्या? अगर किया है तो क्या किया है उसमें? So I need to take some review over here, and at this time only I have to think about my conceptual framework, because all those variables must be there in my study about which I'm going to find out the relationship between, right? So whenever I am finding out or whenever I'm stating out my research problem, my hypothesis statement, I have to go with the conceptual framework to identify the variables, right? Variables कहाँ पे मिलेंगे हमें? Conceptual framework में मिलेंगे, theory में मिलेंगे. So I have to go with the theory. Then I'll come to the formulating of hypothesis. Then your next step will be formulate the good hypothesis, right? Now, after going through the study, once the idea is blinking in your mind, and then you are going with the conceptual framework, some theories, some previous studies and all those things, and then you can be ready to formulate the hypothesis, right? Now, look at this thing. Now you have to try to give the answer of the question which arises in your mind. What was the question? Once again, do students who attend more lectures get better exam result? Now this may be the answer. What is the answer? Attending more lectures leads to better exam result. Now this is what our assumption. हम लोग ऐसा assume कर रहे हैं कि attendance का effect किस पे हो जाएगा? Exam result पे हो जाएगा. Means if students are attending more lectures, it will give us better exam result. Okay, this is just an assumption, not the fact. Okay, yes. Now here you can refine your hypothesis. How we can refine our hypothesis? We need to make sure that hypothesis, whether the hypothesis is specific, whether it is testable. Okay, then how you can check this? Whether it is testable or whether it is a specific, right? Then how we can check it? By considering these three facts. Your hypothesis must contain these three things: the relevant variables, the specific group which is being studied, the predicted outcome of the experiment and or analysis. Okay, these three things you need to consider while refining your hypothesis. Now, this is the time to phrase your hypothesis. Here, I can give you 3 hints to phrase your hypothesis by three way. Okay, there is not the only way to frame our hypothesis or phrase our hypothesis. By three way we can frame or phrase our hypothesis. How it is? Look at these things. To identify the variables, you can write a simple prediction in if and then format. If then format आप सबको पता है, you all are aware of this format. If then, okay. The first part of the sentence state the independent variable. This is important for us now. The first part which starts with if, that is what the first part, that is that must be independent variable, and the second part states the dependent variable. The second part, यहाँ पे जो second part रहेगा वो क्या होगा? Dependent variable, right? So how the hypothesis first statement will be there. If a first year student start attending more lectures, then their exam scores will improve, right? Attending of lectures and exam score, these two are the variables. Independent variable is score, attendance, sorry, and this exam score. Likewise, look at these two hypotheses. In academic research, hypothesis is more commonly phrased in terms of correlation or effects, where you directly state the predicted relationship between the variables. As I said, we are trying to identify the relationship between the variables in the hypothesis, right? The number of lectures attended by first year students has a positive effect on their exam score. Now, what we have considered over here? Number we have considered, right? So number of lectures attended and then positive effect on their exam score. Likewise, if you're comparing two groups, the hypothesis can state what difference you expect to find between them. So first year students who attended most lectures will have a better exam score than those who attended few lectures. I hope you got it, right? Okay, so by these three ways, we can frame or phrase our hypothesis in a good manner. Right now, this is what important for us, writing a null hypothesis. What is null hypothesis and what is alternative hypothesis? We have seen just now. So if your research involves a statistical hypothesis testing, you will also have to write a null hypothesis, because null hypothesis we are considering as a testing hypothesis. Whatever test we are going to apply, we are checking with the null hypothesis itself. So the null hypothesis is the default position that there is no association between the variables. The null hypothesis is written as H0, while the alternative is either H1 or H8, as we all have just discussed these things, right? Now, in our example, look at the null hypothesis. The number of lectures attended by first year student has no effect on their final exam score. Now here what we are saying, there is no relationship between the lectures attendance and effects on the exam score. No relation at all in these two variables. Whereas the alternative hypothesis will show the relation. How it will be? The number of lectures attended by first year students has a positive effect on their final exam score. So we are showing here the relationship between the variables. So likewise, we need to write our hypothesis, null hypothesis and alternative hypothesis. So please to remember, I hope you understood all these things. What is the meaning of hypothesis, how we are stating the hypothesis, how we are formulating the hypothesis, in what way we can formulate the hypothesis, and how we can formulate the null and alternative hypothesis. See, this is the basic part of our hypothesis testing. Once we will identify the variables, all of you, please do remember that identifying variables is really very essential, because on the basis of variables only you're going to test your hypothesis. So that is really important. Now look at these things, terminologies. There are some terminologies in hypothesis testing which you must aware of. Once you will understand these terminologies, hypothesis testing will be very easy for you, right? So the first terminology, that is parameter and statistics, right? A parameter is a summary description of a fixed characteristic or measure of the target population, and that's why we are calling it parameter. Parameter generally we are considering for the population, the whole population, right? If your research area, if you have decided a research area, say for example you are considering the students of first year students, so total students of the first year will be your population, and whatever summary description you are giving from that population, that is what called parameter. So parameter generally we are taking from the population, and that is denoted by the mu, right? And we are taking the summary description in sense of mean, that is mu, then variance, then standard deviation, then proportion. Likewise, we are calculating it from the population itself. So that is some mu is called as population mean, population variance, population standard deviation, population proportion. Please to remember these things, because we are going to apply all these things in hypothesis testing, actual testing. Okay. A statistic is a summary description of a characteristic or measure of the sample. Yes. From the population, we are selecting some samples. Random selection. These are what the random selections we are taking out. And then we are denoting it the sample. Right? I guess tomorrow you're going to study sample in detail, sample survey, how to select sample, what are the types of samples are there, how you can find out the sample. So you can study all these things tomorrow. So randomly we are selecting some samples because it is not so easy to study the whole population in any of the research study. There are a number of, disadvantages of this. Yes, of course, advantages are also there, but time and money is the constraint to go with the population study. So instead of going to the whole population study, we are going with the sample study. And for that, what we are doing? We are selecting randomly samples from this population, and that is what called. And now, after selection of these samples, a summary description of these characteristics of the samples or measures of the sample is called as statistics. That's it. And for that, we are saying sample mean, and we are denoting this by X bar, then sample variance, then sample standard deviation, and then sample proportion. So these two things are really very essential for us when we are actually going for testing of hypothesis, whenever you are using the test statistics for various hypothesis testing, right? Please do remember this. Population mean, sample mean. These two are different. How they are different, we will again study. But here, please, for the sake of understanding, you understand that these things we are parameters we are considering from the whole population, and statistics we are calculating from the sample itself. Okay. Now, yes, this is what important again for us. Sampling distribution. Sampling distribution. I'm not getting pain over here. Why? I don't really understand. Omar sir, can you please help? Hear me? I'm not getting pain over here. Okay, fine. Annotation में पेन क्लिक नहीं हो रहा है. Okay, fine. It's okay. Sampling distribution. Okay, so sampling distribution, as you know, let me make you understand by this diagram itself. First of all, see here, just now we have studied that this is what the parameter. Parameter means what? This is a population, the whole population. Now here we are taking some samples. Out of this population, we are selecting some random samples, or and that size could be n, whatever would be the size of your sample, random samples of size, and we are considering, and that is what the statistic, right? You got this? Right. Now statistic may be different, means whatever random samples are there, they may be different. It may be one type of sample, it may be another type of sample. Likewise, look at this this diagram, you will understand. Say for example, 1, 2, 3 is your population. Now in one sample size, you can consider 1 or 2, 1 and 2 are your samples in one statistics, whereas sometimes you can consider 3 and 2 as your sample. Sample could be anything. Why? Because we are selecting randomly the samples out of this population, right? So samples could be anything, and there will be n number of samples like this. Combination of samples will be like this. Okay. Now you can first of all identify the mu. What is mu? Mu is the population mean. How we can identify that? Very easy. If the population is known, it is so easy to identify to calculate the population mean. How we'll do this? 1 plus 2 plus 3 by 3. So this is what our population mean, right? But this is what the sample mean. X bar is the sample mean. Now here samples, we are taking different sample sets over here. From different sample sets, we can get a different sample mean. Am I right? Yes. So likewise, if you consider these many sample sets like 1, 1, 1, 2, these may be the samples because we are not restricting ourselves over here. We can take any of the sample set out of these, right? But not necessarily the mean of all sample sets will be the same, right? Okay, so how it will be? Suppose this is what the sample set 1 1. So iska mean kya ho jayega? 1 1 2 1.5 1 3 2. Likewise, a different mean calculation will be there. Now look at this graph. Here, this is what sample mean. These are what the different sample means we have considered, we have calculated over here. And then this is what the distribution. If I take this, then it will be curve, bell-shaped curve you will be getting over here. But this is what called sampling distribution. Please to remember. Now generally this sampling mean, now here n number of means we are getting, sample means we are getting. Then what is the population mean? What is the population mean? 2 over here, and here the frequency of this mean is also same. So 2 here we are getting at the large frequency, and that's why we are considering 2 as a sample mean as well, right? So what is the population mean? 2. And what is the sample mean? 2. So generally, whenever we are talking about the sample mean, it is equivalent to the population mean. Okay, and this is what called sampling distribution. Through the sampling distribution, automatically we will get the population mean equal to the sample mean, or sample mean equals to the population mean, right? I hope you understood this. But this is very important in our hypothesis testing. You please do remember this. Yes, the interested part of hypothesis. Okay, many of us, those who are research scholars or just entered in a research area, research field, and then they are trying to find out the hypothesis testing for themselves, or they're just stating the hypothesis and they don't know how to go ahead with the test and all those things. For them, this is very important. Please to remember, this is what called one-tail test. See, a one-tail test is a statistical hypothesis test in which the critical area of distribution is one-sided, so that it is either greater than or less than a certain value, but not both. If the sample being tested falls into the one-sided critical area, the alternative hypothesis will be accepted. Look at this thing. Look at this curve. Okay, here we have defined a certain area. This is what the portion we have defined as a critical region or critical value. First of all, we need to identify. Once we will identify the critical value, then the value of your mu is greater than the actual value. Say, for example, let me give you the example. If suppose what we can say, wafers manufacturing company is there, and if suppose their average manufacturing a day is 100 kgs, right? 100 kgs is the average manufacturing rate. Now 100 kgs is average, means it's a mu, population mean. And suppose you are saying that your mu is greater than 1000. If you wish to check this, and if you just want to check whether your mu is greater than, then you have to go with one tail test, and that too again a right hand tail test. Okay. What we need to remember over here, whether mu is greater than or smaller than. If mu is greater than the value you are considering for your study, then you have to go with the right tail test, right? Okay. And when your mu value is less than the value you are considering for your study, then you have to go with the left hand test, okay, or left tail test. Please to remember these two differences over here. And this is what a critical region we are finding out for our study. Okay, likewise two-tail test is there. As we said that there is a difference between the mean, the sample mean and population mean. It may happen, right? Yes, it may happen. The value which we have calculated and the mean, the population mean, there should be differences. And whenever such differences are there, and if we are denoting differences like this, that there is no difference, no greater, no smaller, just we are denoting no difference, then at that time we have to go with the two-tail test. Okay. Now, whenever we are going for two-tail test, by convention, two-tail tests are used to determine significance at the 5% level. Meaning, each side of the distribution is cut at 2.5%. 2.5%, 2.5%. We are considering this as a critical region because we are not accepting, if the value falls under this region, we are not accepting the null hypothesis. And that's why we are considering this as a critical region. But we are testing whenever we are going with such kind of hypothesis where we are comparing the mean with the population not equal to in that particular sense, then we are going with the two-tail test. Please to remember. So here we are not considering. This will clarify in a better manner to you. When we are going two-sided test, then we are using this sign, equal. Two-sided, equal. Are you getting my point? Bell shape, if two-sided are there, then we are considering it may be for the right side or it may be for the left side. Okay. When we are going for the left side, here please to understand or please to remember that we are not changing at all the null hypothesis. Null hypothesis will remain same because we are just changing the alternative hypothesis over here. Whenever we are going for left side or right side, we are just checking whether it is greater or smaller. Greater or smaller. That's it. If mu is smaller than the value, then go for the left side test. If mu is greater than the value, then go for the right sided test. That's it. Now this is what important again for us. These are what the different test statistics available, and number of tests are available over there. We are going to see soon all those tests. But before that, let us just understand these are what the hypothesis tests, Z test, T test, ANOVA, chi-square. These are what the test, and for that we are using test statistics, Z statistic, T statistic, F statistics, and chi-square statistic. Okay, fine. Okay, this you need to understand. Whenever you are going for hypothesis testing, you must understand this type 1 error and type 2 error. What is type 1 error? It occurs when the sample results lead to the rejection of the null hypothesis when it is in fact true. Look at the picture, you will get very easily. What we are saying here in this picture, type 1 error. You are pregnant. Do you believe this? The doctor is saying to a man that you are pregnant. Is it true? No, not at all. Okay. So such kind of errors are called as type 1 error. These are what? Type 1 error. Why? Because the null hypothesis is true. What is the null hypothesis? A man cannot be pregnant ever, right? So reject the null hypothesis, right? So यहाँ पे null hypothesis is false. Then correct the outcome. Type 2 error. What is the type 2 error? It occurs when based on the sample result, the null hypothesis is not rejected when it is in a fact false. Look at this picture, you will understand. Type 2 error. You are not pregnant. Although the fact is there, the lady is pregnant and still the doctor is saying that you are not pregnant. This is a silly thing we can see. But yes, this happens while going for the research, such things happens. And that's why these are the errors. Now this is what type 2 error, right? Why? Because it failed to the reject null hypothesis when the null hypothesis is false, right? Okay, please do remember type 1 error and type 2 error. One more thing I would like to tell you that type 1 error is denoted by alpha, whereas type 2 error is denoted by beta. And these calculations also we have to go for. Now look at this thing, level of significance, that is alpha, type 1 error. The probability of making a type 1 error, and it is denoted by alpha. Yes, of course, type 1 error. And it is denoted by alpha. Type 1 error can happen during our studies. You can understand this. Whenever you will go for the study, whenever you go for collecting the facts, you can understand, yes, of course, there are some errors which can comes under the type 1 error. Okay, and for that we are saying alpha over here. So alpha is the maximum probability that we have a type 1 error, right? For a 95% confidence level, the value of alpha is 0.05. This means that there is a 5% probability that we will reject the true null hypothesis. Yes. Sometimes it happens that we can reject the true null hypothesis, although there is a truth, but we can reject due to the collection of the data, due to the ununderstandable of the concept of the respondents or samples, and just because of that we can have the probability, and that is a 5%, just 5% probability by which we can reject a true null hypothesis, and that we need to consider. So this is what the rejection regions in this, and this is what the significance level. Okay. Yes, p-value. P-value is defined as the smallest value of alpha. Yes, we are defining the value of alpha. We are defining the error value, means we are defining a value for the testing of hypothesis, the alpha for which the null hypothesis can be rejected. If the p-value is less than alpha, then we reject the null hypothesis. Please do remember this, very important for us. P-value, for this we can get a table. We can get a proper table for p-value. Don't worry for this. Okay. But based on some statistics, based on some techniques, we can go with the first of all calculation. And once we will calculate the value, then we will check with the p-value. If suppose the p-value is less than alpha, alpha is what? Type 1 error which we have calculated, we reject the null hypothesis, right? If the p-value is less than the alpha, then we reject null hypothesis. If the p-value is greater than alpha, we do not reject the null hypothesis. Agar p-value आपका यहाँ पे आ रहा है कहीं तो you cannot reject the null hypothesis. Okay, greater than or equal to as well. Yes. Now this is what the procedure of hypothesis testing. What kind of procedure we are following to test actually the hypothesis. The first thing what we are doing here, we are stating the null and the alternative hypothesis. Then we are stating the significance level by considering the type 1 error, right? It depends on the population, the data which you're going to study. So on the basis of that, we are deciding the significance level. Then we are deciding a test statistics like Z test, T test, F test, or non-parametric test. We don't know what test is suitable at that time for our data. So accordingly, we have to select a test which test is suitable for our hypothesis. Once we will decide this test is okay, then we have to go with the calculation, then calculate the value of test statistics. Then we have to calculate the p-value at a given significance level from the table. As I said, we will be getting a table for the p-value, and we need not to worry, but we have to define our alpha, because on the basis of alpha only we are going to check the p-value in the table. So once we will identify the significance level and alpha, then we can check easily this in the table. Then we will go with the compare of p-value with the calculated. Here is the decision point. Please look at this point. So what we need to do here, we have to compare the p-value with the calculated value. If suppose p-value is greater than the calculated value, please do remember this. New entrants in the research, please do remember this. If p-value is greater than the calculated value, then please accept H0. Okay. If p-value is smaller than the calculated value, please reject H0. As I said that these tests, these hypotheses, we are testing on the null hypothesis only. Please don't go check with the alternative hypothesis, because automatically, suppose we are accepting the null hypothesis, then alternative hypothesis get rejected. When we are rejecting null hypothesis, then automatically the alternative hypothesis get accepted. Okay, so don't think about that. We have to just test hypothesis on the basis of null hypothesis itself. Okay, yes. Before going through the statistics, or what we can say, parametric, non-parametric, this and that test, I just want to make you aware about this thing, that if you're taking tension or burden of testing of hypothesis, first of all, remove it. Okay, why? Because it is so easy. First of all, as I said, we need to identify the variables. See, what we are doing generally, we are making a study, right? Two types of variables generally we are studying in any kind of research, any kind of study, right? For the sake of example, I have taken over here the gender. Okay, gender is one category, gender is one variable you can consider over here, right? But which is qualitative one. This we cannot measure in the quantity. So this is what a qualitative variable. Likewise, age group here, adult, child, elderly I have considered. So this is again qualitative. Height I have considered over here, and weight I have considered. So these are what the quantitative variables, right? Now, these qualitative variables are considered as a categorical variables, right? And they are not denoting in the numerics. We cannot denote male, female in the numeric. Yes, for the sake of statistics, we can consider and we can collect the data by giving the number, 1 is for female, 2 is for male. Likewise, we can consider that. But here, as such, we cannot denote it in numerics. Okay. So we are making two categories of the variables. One is categorical and second is numeric. I hope you are understanding. Okay. Now, when we are going for a numeric variables like height, weight, which we are denoting in the quantity, then we are going for summarizing this, like we are calculating some range, IQR, median, mean, likewise calculations we can perform on the numeric data where it is not possible in the categorical data. And on the basis of these things only, we are going with different tests. Please do understand. Means suppose we are considering one qualitative data and one quantitative data, then we have to go for the t test. If we are considering 2 or 3 variables over here, then we have to go with ANOVA. Likewise, we are going to see all these things in the next slides. But till the time you just understand that these kind of data, these kind of figures we are getting when we are collecting the data for our research, either it may be in the categorical form or in the numerical form. I hope you are understanding this. Okay. So just we are checking. Suppose I want to understand the relationship between the gender and their height. Whether there is a relationship between the gender and the height, it may be there. So that we need to calculate. And for that we have to use, now we are going to check over here the relationship between gender, means the categorical variable, and the numeric variable. So for that I have to use t-test, right? So if one is categorical and one is numeric, for that I have to go for t-test. If both are categorical, I have to go for non-parametric test, right? If both are numeric, then I have to go for t-test or f-test, okay? Or more than 2-3 variables I'm considering at a time and I'm going to compare at a time, I have to go with the ANOVA likewise, okay? Now these are what the test statistics. I hope I have time with me. Yeah. So statistical tests are considered to test the hypothesis and to find out the inferences about the population. Yes. So we are getting some conclusions regarding the population, and for that we are testing our hypothesis. See, whenever we are testing our hypothesis, it means that we are trying to reach the conclusion, or we are getting some inferences about the whole population. Samples we are testing, it's okay, but how we are testing our samples which are derived from the population, and the intention behind testing of these samples is to identify the characteristics of the population, whatever assumptions we have made for the population, that we are showing through the statistical test. Okay. For that, samples are selected and various tests are performed on them to find the inferences about the population under study. And for this, there are two types of tests which generally we are following. One is parametric test and second is non-parametric test. Now, how these parametric tests, non-parametric tests acting, or when we are considering these tests, or what test we are considering under these parametric and non-parametric tests, or when we are going to apply these tests, that we will discuss, right? Check once again the flow. Once we will understand the meaning of hypothesis, we will go for stating of null hypothesis and alternative hypothesis, and then we are applying the testing, hypothesis testing. For that, we are selecting a statistical test, that may be the parametric test or non-parametric test, right? So let us understand what is parametric test and what is non-parametric test. Let me take it first because I have less. Okay, so this is a statistical state in which specific assumptions are made about the population parameter, is known as a parametric test. So instead of this, I would like to tell you this thing, that which is very important for us, that the data must be normally distributed. So a bell-shaped curve must be there. Now, let me give you the example. If suppose, just assume that here is the curve, we are getting such kind of bell-shaped curve from the distribution of values of our data, then only we are applying the parametric test. Okay, parameter, you can understand by the word itself, right? Parameter means what? Population. So we are first of all checking whether our population is normally distributed or not. How to identify that? On the basis of bell-shaped curve. Say for example, I'm checking the height of, I'm considering the height of men, or we can say the average height of population, the average height of population. So here, if suppose we are considering less likely or most likely, and suppose the small or what we can say shorter and average, and then we get tall. So here we can get a curve like this, and that will be considered as a bell-shaped curve. right? Example I have taken over here as well. Height is roughly a normal distribution in that if you were to graph height from a group of people, one would see a typical bell-shaped curve. Yes, if you consider a particular group of people and if you check their heights, then it will you will definitely get a bell-shaped curve. This distribution is also called as a Gaussian distribution. You might know that. So parametric tests are in general more powerful. Parametric tests are more powerful. Why? Because they require a smaller sample size because they are normally distributed. If we take different samples out of such a population, so they can give us a correct result, and that's why they are more powerful than the non-parametric test, right? Please to remember. Yes. Now, whenever we are going for the parametric test, this test comes under the parametric. If the sample size is large, means if suppose the sample size is more than 30, you have to go with the Z test. Okay. If this small sample size is there, it may be less than 30 or equals to 30, you can go for T test. Okay, in t-test also we are having two different tests, that is independent or unpaired t-test or paired t-test. And then the third one is ANOVA, that is analysis of variance, for which we are using F statistics. There are also two types, one-way ANOVA and two-way ANOVA. Okay, now look at the Z-test first of all. Z-test is used for testing the mean of a population versus a standard, or comparing the mean of two populations with a large samples, whether you know the population standard deviation or not. Okay, so not necessarily, if you don't know the standard deviation of the population, then also you can go with the Z-test. Z-test we are basically using to show the differences between the variables. Please do remember this. We are using Z-test to show the differences between the variables, right? But this test specifically we are using for the large samples that you need to remember. Okay, if it is more than 30, then you have to go with the Z-test. That is important. That is important for us. In Z-test also we can get two sample tests, that is one sample Z-test and two sample Z-test. If you want to compare a sample mean with the population mean itself, then go with the one sample Z-test. If you want to compare the mean of two different samples, then go with the two sample Z-test. Okay, these are what the formulas. If you wish to write it down or take the snapshot of it, you can. So by this way we can calculate the Z-test. Again, what I'm saying here, we are checking the deviations, differences between the variables through the Z-test. Yes, it is also used for testing the proportion of some characteristics versus a standard proportion, or comparing the proportions of two population. Yes, as I said, for comparing the proportions, we are using Z-test. For example, comparing the average engineering salaries of men versus women. Here we are considering two variables, salaries of men versus salaries of women. So we are comparing these two things, and for this we are using Z-test. Another example, comparing the fraction defectives from two production lines. Yes, two production lines we are considering over here, and then what we are comparing the fraction defectives. So for the sake of comparison or to identify the differences, we are using Z-test. T-test. T-test also we are using for checking out the differences, but T-test we are using for the small sample size, that is less than 30. It has mean 0. It has variances greater than 1. It is a bell-shaped systematically distribution about the mean. These are what the properties of T distribution. Some assumptions we are making for the T-test, that is sample must be random, observation dependent, standard deviation is not known, normal distribution of the population. These are what the conditions or assumptions we are making while going with the T-test. All you please to remember, it is very important to go with the sampling theory. If your sample selection is correct, then your next rest of the things related to hypothesis testing will be very smoothly, and you can easily find out all these things. So sample selection is the very important part of your research, right? Uses of t-test, why we are using the mean of the sample. Yes, we are calculating the mean of the sample, the differences between the mean, or to compare two samples. Yes, of course, two samples comparison we can do in t-test, in z-test. Okay, and we can even go for the correlation coefficient. To identify the correlation coefficient between two variables, we can go with the t-test. T-test also has two types, that is pair t-test and unpaired t-test. You can go with two sample test or one sample test in t-test as well. Okay, if suppose here one sample t-test, the formula we are using this formula. Why? Because we are compare the sample mean with the population mean, and here we are comparing two different samples itself. So if we are having two samples, then go with two sample t-test. If we are having only one sample mean and we are comparing this with the population mean itself, then go with this. Say for example, if I want to identify the male female ratio in a particular population, male female ratio in a particular population, I can go with the one sample test. If I want to identify the male female and their relationship between the their association with the height or weight, okay, so then I'll go with the two sample t-test. Now, this is what important for us. If the value of test statistics is greater than the table value, here we are calculating the table value. You know, once we will calculate all these things, then we are checking with the table value, right? If the value of test statistic is greater than the table value, so whatever value we are getting by calculating these things, that is what called test statistic value. If it is greater than the table value, then we have to reject the null hypothesis. If the value of test statistic is less than the table value, then do not reject the null hypothesis, means what? Accept the alternative hypothesis. Okay, this is what the pair t-test. Let us just go with this thing. Consists of a sample of matched pairs of similar unit or one group of unit that has been tested twice, a repeated measure. For example, by the example you will understand very easily. Where subjects are tested prior to a treatment, say for high blood pressure, and the same subjects are tested again after treatment with a blood pressure lowering medicine. So here what we are doing, we are comparing two times the same thing, means we are using the repeated measures over here. What we are doing here in this example, the high blood pressure, we are checking before any treatment and after any treatment. So you might know that before something you want to check, and after experiment, before experiment you want to check something, and after experiment. So at that time you have to go for the paired t-test. Okay, unpaired t-test. When two separate sets of independent and identically distributed samples are obtained, one from each of the two populations being compared. Compare the height of the girls and boys. Just a second. Hello. Sorry. Hello. Huh? How is it? हाँ subway station. Okay, this is what the unpaired t-test. Yes, I got a call that I have to finish my lecture session now. So just have a look on these things. When we are using t-test, when sample size is small and then the population variance is not known, If the population variance is not known, we can go with the t-test. But whenever the sample size is large and the population variance is known, we can go with the z-test. Sometimes see what happens. The sample size is also large and the population variance is also not known. That time what we need to do, we have to go with the z-test itself. Why? Because we cannot go for the t-test when the sample size is large. So at that time also we have to go with the z-test by using the different formula. When sample size is small and the population variance is known, that time we can use z-test as well. When the variance is known, why? Because this is what the another condition of z-test to know the variance. If it is known, then we can go for the. Okay, fine. This is what the analysis of variance is. Suppose if we want to compare more than 2-3 groups at a time, or what you can say relations between 2-3 groups or more than 3 groups, then we have to go for the ANOVA, that is analysis of variances. And for that, one-way ANOVA is there, two-way ANOVA is there. I hope you understood. We are getting very less time to complete our session. Non-parametric test is there when there is no normal distribution is there. So we have to go for non-parametric test. These are what the commonly used non-parametric test. I-square we are generally using. Okay. So this is what the test statistics we are using for chi-square. Thank you so much. Thanks a lot for paying attention. And I'm really very sorry we are not able to cover the whole things due to the less time available with us. Yes, thank you so much. Thank you all of you. If you'll be having any questions, you please write in the chat box. I'll give the answer.
Yes, anyone have any question? Please ask.
One question, ma'am. Hello.
Hello. Yes.
One question, ma'am, from participant Sagar Sant. He asking question. Question is, what is mean by correlation coefficient?
Okay, so it will take time. If we have time, then go ahead with this, because it will take time. Correlation coefficient to make you understand. Okay, shall I do one thing? Shall I share some documents with the participants so that they can understand? Sir.
Okay, ma'am. Okay, ma'am.
Okay, sir. Yeah. Okay, sir. Okay. Okay, fine. I'm sharing document with all the participants so that you can get the answer of your question very well. Because I guess the next speaker is waiting.
Yes,
sir,
yes,
you
yes.
just give me the question so that I can make the I can give the reply on their personal. Yeah.
Okay.
Fine. Thank you so much. Thank you all of you.
Yes, I'm very thankful to Dr. Rajashree Badage madam for her detailed presentation on hypothesis testing. Once again, thank you, ma'am, for your nice presentation.
Thank you so much, sir. Thank you. I hope all participants understood the concept. Those who are new in the research area, they understood the concept of hypothesis testing, at least at the some extent. Yeah, thank you so much. Thanks a lot.
Yes. Now here our first session of afternoon is finished. Now we will start our next session. Our next speaker is waiting. I will introduce him in brief. The next session speaker is Dr. Vinod Vijay Kumar Kharat. Currently, he is working as assistant professor in mathematics at NB Naule, Sinhagad College of Engineering, Solapur. He is having near about 15 years of teaching experience. He is having few achievements. He is a reviewer of he is a reviewer of mathematical reviews, Math Senate of American Mathematical Society. He has recognized as a PG teacher and research guide in mathematics by Punyashlok Ahilyabai Holkar, Solapur University, Solapur. He has recognized by Vishweshwarya Technological University as a research supervisor. He is an executive member of Shivaji University Mathematical Society and life member of Indian Mathematical Society. He has published one handbook of mathematics formally for FY BTech of Punyashulik Ahela Devikar Solapur International Journal and 12 in national journals with 84 citations, 5 H index and 1 I-10 index. He has given more than 19 guest lectures. So with this, I am requesting Dr. Kharat sir to start with his session. Thank you.
Thank you, Pawar sir, for my nice introduction. Am I audible?
Yes, sir, you are audible.
First of all, I would like to thank Principal of SKN Srinagar College of Engineering, Koti, Dr. Kailash Karande sir, Head of General Science and Engineering, Professor Nikam sir, Convener of this FDP, Professor Pawar sir and team for giving me an opportunity to interact with all of you. Today's topic is such an interesting one as this provides an excellent tool to describe many of the physical phenomena or systems or processes. As you can see the topic on the screen, differential equations and its applications. So this is outline of my today's presentation. Introduction, modeling with differential equations, fractional differential equations, applications and references. The purpose of this talk is to introduce the differential equations and its applications in a gentle manner rather than the usual definition, lemma, theorem approach. As a mathematician, we know that it has several branches that deals with beautiful and interesting concepts. One of that is calculus. So one can roughly say that calculus is nothing but differentiation and integration. And all of you are familiar with that derivative and integration as we are from mathematical background. So is fractional calculus, fractional integration and fractional differentiation. So fractional calculus is name of the game. A physical system can be studied in various ways. One among them is to create a similar environment in a laboratory and then study the required characters of the system. Another method is to prove a theory and to verify it experimentally. Both are well-known procedures adopted in practices. So like this, in engineering, we do practicals and then check the theoretical parts. Or in classroom, first we learn the theory and then we can verify by demonstration or practicals. Perhaps the most important of all the applications of calculus is to differential equations. When physical or social scientists use calculus, more often than not, it is to analyze a differential equation that has arisen in the process of modeling some phenomena they are studying. It is often impossible to find an explicit formula for the solution of a differential equation. Nevertheless, we will see that graphical and numerical approaches provide the needed information. So differential equation. A differential equation is an equation which contains one or more derivative terms. It is called as differential equation. So for example, it is dy by dx is equals to f of xy. Here x is independent variable and y is dependent variable. Order of differential equation. The order of differential equation is the order of highest order derivative present in the equation. So degree of differential equation is the power or index of the highest order derivative appearing in that equation. So as we know all that things, so let us take example. So here I can present one example, dqy by dx cube plus dy by dx raised to 4 plus 7y equals to 0. And if I can identify, then order of this equation is 3 and degree is 1. And whenever we can decide that order and degree at that time, we know that that equation must be free from any of that radical sign. So types of differential equations. Differential equations can be divided into several types. So let us take namely ordinary differential equations, partial differential equations, fractional differential equations, or more particularly, so it may be linear differential equations, non-linear differential equations, homogeneous differential equations, non-homogeneous differential equations, or one may categorize with the help of order and degree of that differential equations, or with the help of kernels of that given function. A differential equation contains derivatives which are either partial derivatives or ordinary derivatives or fractional derivatives. The derivative represents a rate of change, and the differential equation describes a relationship between the quantity that is continuously varying with respect to change in another quantity. So in day-to-day life, we experience all that things. What happens with that price of that petrol and uses, and in many more things. There are a lot of differential equations, formulas to find the solution of the derivatives. As we know that in engineering mathematics 2 or in engineering mathematics 3, there are chapters. So there are different types of differential equations. So one may categorize that as homogeneous differential equation, linear differential equation, Bernoulli's differential equation, exact differential equation, non-exact differential equation, or linear differential equation with constant coefficient. And we know that detailed procedure of that solution. So that means for the different categories of the equations, we have different methods to find out that required solution. The question is that how to represent some mathematical models in the form of differential equations. As we know that, so mathematics is queen of all sciences, mathematics is mother of all sciences, and like that. So, but we can conclude that mathematics is nothing but language of all sciences. Through that mathematics, we can develop the things. Formulating a mathematical model of a real-world problem through either intuitive reasoning about the phenomena, a physical law based on evidence from experiments. The model often takes the form of differential equation. So here I can present that diagram. So exactly it gives you. First, we'll start with that real-world problem. Then we can do that analysis and convert that real-world problem to mathematical model with the help of physical laws and other things. Then we can solve that equation mathematically, and then with the help of that solution, we can interpret that result. So this is the general flowchart. In a real-world problem, we often notice that changes occur, and we want to predict future behavior on the basis of current values changes. So let's begin by examining several examples of how differential equations arise when we model physical phenomena. And recently, we are familiar with that this pandemic situation. So as that changes are going on, so results based on that data we want to predict some results, and according to that we want to plan. So with the help of differential equation, we can do that. So model of population growth. So this is a very basic model, and many of us know that, but let us see in details what exactly that model and how to convert that physical laws in terms of model. One model of growth of a population is based on the assumption that the population grows at a rate proportional to the size of the population. So that is reasonable assumption for a population of bacteria or animals under ideal conditions such as unlimited environment, adequate nutrition, absence of predators, immunity from disease, and so on. The rate of growth of the population is derivative. Whenever there is rate, so let us go with that derivative. So see that whenever we can watch that cricket match, so again in that cricket match, we are interested in run rate. So that means whenever there is a rate of change, so that derivative comes. So we can formulate that in terms of differential equation and we can try to find out its solution. Hence, the rate of growth of the population is proportional to the population size, and hence I can model that as dp by dt is equals to k into p. Here k is proportionality constant, p is independent variable, p defines number of individuals in the population, and k is proportionality constant. And see that always that growth increases, therefore I can take that proportionality constant as plus k. So this is our first population growth problem. Let us take or let us see what are its consequences. If we rule out a population of 0, then p of t is greater than 0 for all t. So if k is greater than 0, then equation 1 shows that p dash of t, that is derivative, is greater than 0 for all t. This means that the population is always increasing. So in fact, as p of t increases, equation 1 shows that dp by dt becomes larger. In other words, the growth rate increases as the population increases. Equation 1 asks us to find a function whose derivative is a constant multiple of itself. Now, whenever we can put some equation, let us try to interpret that equation. What are the meanings of that? And then analyze. We know that the exponential function have that property. In fact, if you let p of t equals to c into e raised to kt, where c is constant, then its derivative p dash of t, by using usual calculations, we can get as k into p of t. So that means that derivative is constant times multiple of its function. Thus, exponential function gives a solution of equation 1. Now see that here, let us represent pictorially. Allowing c to vary through all the real numbers, we get the family of solutions p of t, whose graphs are shown here. Now see that here values of c may be positive, may be negative. Here we allow all the values of c. So then solution is like this. However, populations have only positive values. So we are interested only in the solutions with c greater than 0. Also, probability we concern only with values of t greater than the initial time at t equals to 0. Now, if I can consider that at t equals to 0 or greater than 0 for c greater than 0 and time t greater than 0, then our solution represents in this way. Putting t equals to 0, we get p of 0 equals to constant. So that reduces to initial population, and that initial population gives you p of 0, that is nothing but c. So equation 1 is appropriate for modeling population growth under ideal condition. Now whatever we are doing that right now, so it is under ideal conditions. So however, we have to recognize that a more realistic model must reflect the fact that a given environment has limited resources. Many populations start by increasing exponentially. However, the population level of when it approaches its carrying capacity or decreases towards k if it ever exceeds k. dp by dt is approximately k into p if p is small, and dp by dt is less than 0 if p is greater than k. A simple expression that incorporates both the assumptions, so it is given by equation 2, and this equation 2 is called as logistic differential equation. So it was proposed by a Dutch mathematical biologist in 1840. And if p is small compared with k, then p by k is close to 0. So we have dp by dt is approximately equals to k into p. And if p is greater than k, then 1 minus p by k is negative. So that dp by dt is less than 0. And we are through. So let us develop techniques that enable us to find explicit solutions of the logistic equation. We can deduce qualitative characteristics of the solution directly from the equation 2. Or we first observe the constant functions p of t equals to 0 and p of t equals to k. So these two are the solutions. And whenever we can observe these two, so these two are very important solutions. So that gives you equilibrium state. So this is because in either case, one of the factors on the right side of equation 2 is 0. And certainly it makes physical sense. If the population is ever either 0 or at carrying capacity, it stays that way. So these two constraints are called equilibrium solutions. If the initial population P of 0 lies between 0 and k, then the right side of equation 2 is positive. So always dp by dt is increases. So however, p is greater than k, so it is negative. So that dp by dt is less than 0, and we can say that population decreases. Notice that in either the case, the population approaches the carrying capacity, then dp by dt tends to 0. This means that the population levels off. So we expect the solution of the logistic differential equation. So just take the look of this graph. Now see that what happens with that equilibrium conditions. Notice that the graph moves away from the equilibrium solution for p equals to 0 and move towards the equilibrium solution when p equals to k. So that is the interpretation with the help of graph. Now recently, so many authors are studying that growth problem for that pandemic situations. At the end, we'll discuss that. Model for motion of a spring. Now, let us take physical example from physical sciences. We consider the motion of an object with mass m at the end of a vertical string, as shown in that figure. Now, if the spring stretched or compressed x units from its natural length, it exerts a force proportional to x. And we can say that restoring force equals to minus k into x, where k is positive constant and k is spring constant, or you can say that k is spring stiffness. If we ignore any external resisting forces due to air or friction, then by Newton's second law, m into d2 by dx dt square is equals to minus kx. So given by equation 3. So this equation represents second order differential equation as it involves second order derivative. Now let us see that we can guess about the form of the solution directly from the equation, or equation 3 can be written as in this form, d2x by dt square equals to minus k by m into x. So this says that the second derivative of x is proportional to x but has the opposite sign. Now we are familiar with that derivative. Can we guess is there is a function that satisfies that given differential equation which gives you, or a second derivative is proportional to negative of that function? We know that two functions with this property, the sine and cosine functions. It turns out that all the solutions of equation 3 can be written as a combination of certain sine and cosine function. So that involves trigonometric functions. Now again, let us take another example of differential equation. Let us start with RC circuit. A resistor is any circuit component. So by Ohm's law, we can write down that as V equals to I into R. Now for that capacitor, we can write down this as V equals to Q by C. So all of you are familiar with that notations V, I, R and Q. Now if I can equate that values, then I can write down this equation in terms of minus dq by dt into R equals to Q by C. So or equivalently I can write down dq by dt equals to minus 1 upon RC into Q, which is again first order differential equation. And we know that how to get that solution, and it again solution is given in terms of exponential form, q equals to q naught into e raised to minus RT. Or one may take some example of RL circuit. If I can go that RL circuit, again if I can apply Kirchhoff's law or Kirchhoff's voltage law, I can write down or I can model that as again first order differential equation. And we know that how to measure that current across resistor. So it is I into R, and current across inductance, so it is L into di by dt. So that gives you again first order differential equation. So that means, so the differential equations are very important for analysis of circuits. Or rather, one may go with that for that solution of circuits by using differential equations. If I can involve more than two series or more than two circuits, then I may solve that circuits with the help of simultaneous differential equations, or I can say that with the help of system of differential equations, I can solve that circuit and I can find out required values of current. When applying differential equations, we are usually not as interested in finding a family of solutions. The general solution, that is. So we are interested in particular solution. Now, how to obtain that particular solutions? For that particular solutions, we require particular values of dependent and independent variables, and we can put that condition in terms of y of t naught equals to y naught, and such type of condition is called as initial condition. The problem of finding a solution of the differential equation that satisfies the initial condition is called an initial value problem. Similarly, if I can vary that conditions, if I can go for that boundary condition, then it will be boundary value problem. Or sometimes I may impose integral conditions, or I may impose fractional integral conditions. According to your need, you may change that conditions and you can find out that solutions. Now see that whenever I can go for that integral conditions, if that function on that boundary is connected to that domain, then I can go for that boundary value problem, integral value problems. Now, strong form of boundary value problems. So here I can list some of the examples. So here it is elastic bar, string in tension, heat conduction, flow through a porous medium. Now for that elastic bar, so let us consider axially loaded elastic bar, and here I can express the terminologies that involved in that equations. So A, B, E, U, and X. Now, if I can write down its differential equation, then governing equation is of that form: d by dx of A into E into du by dx plus b equals to 0. And this is second order equation. Now, for that required particular solution, we required boundary conditions. Now, here I may impose boundary conditions, so such that it is Dirichlet or it is displacement boundary conditions. One may use that Newman's or force boundary conditions. So according to your problem and your aim, so you can impose that conditions and you can try to solve that equation and find out particular solution with the help of that boundary conditions. Now, next part of this talk, so it is fractional differential equation. Now, whenever we heard that word fractional, so something is that is exist or it is just a fantasy. So many questions are arises in mind. Now, whenever we used to write down nth derivative, so for that nth derivative, we can use that generally notation d raised to n f by dt raised to n. So 30 September 1695, L'Hopital asked to Leibniz, what if the order will be n? So that means just you can imagine. So n equals to half. So that means it is d raised to half f by dt raised to half. That means it is half order derivative of function. Now we are familiar that integer order derivatives and their respective formulas. So first order derivative, second order derivative, and like that. And we know that is geometrical interpretation and physical interpretation. First order derivative, that means it gives you rate of change, it gives you velocity, it gives you tangent and slope and so on. Second order derivative, it gives you acceleration. Now see that. Now, if there is any derivative between that first order and second order derivative, if I can consider velocity and acceleration. Now, whenever we can take a look of highway, so on that highway, vehicles are moving, and if I can observe, just you can see that vehicles are, it is just interpretation, vehicles are moving in a straight line, but it is possible to move that vehicle in a straight line? No, that means exactly there is some derivative between that integer orders. So that as real numbers are exist between two natural numbers. So that means fractional derivatives are exist. So in his reply, Leibniz give that reply. It will lead to a paradox from which one day useful consequences will be drawn. So in these words, So that fractional calculus was born. Some facts about fractional calculus. Nowadays, so rigorous mathematical theory has been developed. So integer order calculus is the special case of fractional order. So geometrical interpretation or physical meaning exists, but not as straightforward as for the integer order derivatives. Just I can tell you. So what is the geometrical and physical interpretation of that first order derivative? So like that for that fractional order, so it interprets shadow on the wall and shadow of the past. So there are more than 15 definitions of fractional derivative operator. Now to define that the fractional derivatives, so special function plays very important role. So I can here put some of these special functions, so that plays very important role in that fractional calculus. So first is the gamma function, second the beta function, and third Mittag-Leffler function. Now generally we are familiar with that gamma function and beta function, and for that Mittag-Leffler function, so if I can vary that parameters, it reduces to some standard functions like exponential function, hyperbolic function, and so on. Now here is the definition of fractional integral and fractional derivative. Now topic is differential equations. Still I will give you the definition of fractional integral, as if I can observe these two definitions, I can define that fractional order derivative in terms of fractional integral. Therefore for that fractional derivative, fractional integral plays very important role. So in this way that Riemann-Leibniz integral is defined by this equation, and by using this equation define that Riemann-Leibniz fractional derivative. Now for example, if suppose my aim is to find out half order integral of x, or sorry, fractional half order derivative of x. So it is half order derivative of x, so it comes out to be 2 into square root of x into pi. So like that, here I can give that some definitions and the respective derivatives. If I can take f of x equals to x and order alpha equals to 3/2, then 3/2 derivative of function x, it is 1 upon square root of pi into x. If you can apply that definition of fractional derivative and you can work out, you will get that result. Or one may go through that the book written by Podlumbi. Now next two concepts are very important. So f of x equals to 1 and alpha equals to half. So that means it is half derivative of 1, and as we know that by using integer order calculus, we know that derivative of constant is 0. But here you can observe that fractional derivative of 1, that is constant, it is not equals to 0. So it is 1 upon square root of pi into x. So again 3/2 derivative of 1, so it gives you minus 1 upon 2 into x raised to 3/2 into square root of pi. Now next definition, that is very important definition. So it is capital derivative. So that overcomes with that difficulty of that fractional derivative of constant. If I can apply capital derivative on constant, then it gives you 0. And capital derivative is defined by equation 4. Now see that in the definition, so that gamma functions are involved. So that means that gamma function plays very important role in that fractional calculus. Now see that applied problems require definitions of fractional derivatives, allowing the utilization of physically interpretable initial conditions. So Capito reformulated the more classical definition of the Riemann-Leibniz in order to use integer order initial conditions to solve fractional order differential equations. Did you notice? Definition of fractional derivative involves an integration. And as we know that integration is a non-local operator as it is defined on an interval. Fractional derivative is a non-local operator. Calculating time fractional derivative of a function f of t at some t equals to t1 requires all the past history from 0 to t1. So fractional derivative can be used for modeling systems with memory. Calculating space fractional derivative of function at x1 at x equals to x1 requires all non-local f of x values. So fractional derivatives can be used for modeling distributed parameter system. Now there are new fractional derivatives. So here I can list some of them. So Machado derivative, chain Machado derivative, Coimbra derivative, Catu-Gampola derivative, Catu-Gampola derivative, Hilford derivative, or it is Psi-Hilford derivative, Davidson derivative, chain derivative, Atagna-Balanou derivative, Pichagachi derivative. Now that Atagna-Balanou derivative, at the end, I will give you one example with the help of that Atagna-Balanou derivative. So situation of that solution for that situation of COVID-19, they can try to give that solution with the help of that Atagna-Balanou derivative and many more. Now see that when we accept all that new derivatives, if it satisfies certain properties or certain characteristics. So what are that characteristics? So let us see in that next slide. Which properties to preserve so that we'll easily accept all that new derivatives? For integer orders, it must gives classical derivatives or integrals. Zero order derivative, so that means that function itself. So it obeys that commutative or index law. Linearity property, it obeys that product rule or it is Leibniz formula. It obeys chain rule. Now, what is fractional differential equation? A fractional differential equation is a differential equation where at least one of the differential operator is of fractional order. At least is important. So at least one of that term is of order fractional. For example, here I can give that example 5. So here, if I can observe that alpha belongs to R plus, where we assume that initial conditions which are given by equation C. Now see that here alpha belongs to R plus. What happens if alpha belongs to R? For that negative values, so it becomes integral, because we know that derivative and integration, these two are anti-processes. Therefore, for alpha belongs to R plus, it represents fractional order derivative. Now, whenever we see such type of equations, immediately in mind there are some questions. Does differential equations have solution? Does differential equation have unique solution? Now, this is basic paper. Who want to start research in that fractional differential equation, so they can start with this paper. V. Lakshmikantam and A. Vatsala. So, basic theory of fractional differential equations. So, it is published in 2008. So, in that paper, Lakshmikantam and Vatsala systematically studied the basic theory of initial value problems for fractional differential equations involving a Riemann-Lively differential operator. So here they can consider this equation dqx equals to f of tx with initial condition x of 0 equals to x naught. They can study that problems or existence and uniqueness by using fixed point theory. Now, if I used to apply that fixed point theory and check that existence and uniqueness, so for that existence and uniqueness, Banach fixed point theorem is most useful tool, as it gives both guarantees the existence and uniqueness of a fixed point. For this, first consider the operator, so which is the solution of this differential equation. Then we show that it is contractive mapping and it is invariant, and we through by using Banach fixed point theorem. But unfortunately, the requirement that our map must be contractive map. That limits its utility. So again, there are other fixed point theorems are there. So like Schauder fixed point theorem, Schaefer fixed point theorem, Krasnowski fixed point theorem, Leray-Schauder fixed point theorem, and so on. But all the theorems have relaxed that condition on the mapping, but at the same time, stronger the conditions on the domain and codomain. So these theorems only assert the existence of a fixed point, however, not the uniqueness. So in this paper, which is published in 2002, Daltham and Ford have investigated the following type of fractional differential equation, again by using that fixed point theory. Numerous problems in physics, chemistry, and engineering are modeled mathematically by system of fractional differential equations. For example, In reference 1, they have formulated motion of an elastic column fixed at one end and loaded at the other in terms of system of fractional differential equations. For more details, you go through this. Now, in 2011, X. Dong, Wong, and Zhu have investigated the existence, uniqueness of solution to the non-local problems for the fractional differential equations in Banach spaces of the type. So they can study the equation with this non-local condition. Also established new sufficient conditions for the existence and uniqueness of solutions by means of fractional calculus and fixed point theory under some suitable conditions. Under that suitable conditions, or we may call that as hypothesis, under that hypothesis, that given differential equation have existence and uniqueness. Now, first by this we start that working on that non-local initial conditions. Now, next, very important, it is iterative differential equation. The equation in which derivative argument depends on both the state variable x and t of the form x dash of t equals to f of t x of t are called iterative differential equation. Now see that here prime, so it is x dash, so it is ordinary differential equation, so it is ordinary iterative differential equation, and in that next definition, so I can replace that ordinary by fractional dq x of t, and here if q equals to 1, then that reduces to ordinary differential equation. So that means that fractional, that ordinary derivative is a particular case of fractional derivative. And these models or these equations are very important to study infection models. Whenever we can deal with that infection models, already we know that if there is injury for that diabetic patient, then to cover that injury, so it takes a lot of time. Similarly, for that process of curd making, now see that if I can put one drop of curd and after some time interval, so complete pot gives you curd. And that means that curd process, so that gives you infection model. And whenever we can study that infection models, we require so iterative differential equations. So in 2016, myself and my research guide Jagtap sir, so we study existence of iterative fractional differential equation with non-local conditions. So which is given by so equation number 7 and equation number 8. And in this paper, we can study that existence and uniqueness with the help of again fixed point theory. Now for that existence and uniqueness, so we consider some assumptions or some hypothesis. Under that hypothesis, so that equation 7 and 8 has existence and uniqueness of solutions. Now here I can list that hypothesis H1, so that satisfies this condition, so that is here, and this condition on G, and H2. So this is H3. So under these different conditions, so H4 and H5. Now first result in that paper, suppose that the hypothesis H1 to H3 are satisfied, and if equation 9 holds, that means this inequality is true, then there exists at least one solution of this system 7 to 8 in CLQ. So here for that solution, so we define that space, so it is CLQ, which can be approximated by the Krasnowski's iteration, which is given by this equation. Now first for that existence and uniqueness of solution, first we can find out solution of this equation 10 and 11, and then a solution of equation 7 and 8, and then we consider operator, then we can show that that operator is invariant and that operator satisfies Lipschitz condition. So then by using Banach fixed point theorem, we can show that that system or that equation has unique solution. And for existence, we can consider that non-expansive mapping. So that means that is strict. If that condition is strictly less than 1, then by using non-expansive mapping, we can conclude that that system has there exists at least one solution. And then by using approximation method, we can show that that is given by this equation. In 2013, myself and my guide, Jagtap sir and Kendre, established the existence, uniqueness and boundedness of solution of nonlinear fractional integral differential equation with non-local condition of the type 10 and 11. So here it is extension of that differential equation. So here, if this integral is equals to 0, then see that this equation reduces to differential, fractional differential equation. That is particular case of that result. Now let us see the applications. Now we'll try to understand the practical and day-to-day life implementation of the fractional order. As you can see, two pictures in this slide. There are the tools which are normally used by us in our daily life for different purposes. For example, repairing of any machines. We do find these tools in the toolkit provided with the two-wheeler or four-wheeler. Also, normally, many of us keep these tools at our home. Picture on the left side is an example of integer order calculus, as these tools are for specific purpose used in workshops, garage, etc. And picture on right side is example of fractional order calculus, because this tool is adjustable. One may refer it as arbitrary. So indirectly, we are applying this concept in day-to-day life. So another example. During this pandemic situation, the saloons and barber shops were closed. So many of us purchased trimmer for haircut. Here, left side picture shows different types of razors which has specific use in saloons. This represents integer order calculus. The picture on the right hand side also represents trimmer with adjustable razor, which is ultimate example of fractional order. So I hope these two examples might have cleared the application of fractional order in day-to-day life. Now see that here I can quote some references. Modeling the dynamics of novel coronavirus with fractional derivative. Now in this paper, so they can use Atagna-Balenu fractional derivative, and with the help of that model, fractional differential equation model, they can find out solution, or they can predict some future results, and they can represent that results with the help of graphs. So those are interested in that modeling, so please go through this paper. Again, one more example. So mathematical model of COVID-19 using fractional derivative. So outbreak in India with dynamics of transmission and control. Now for that result, they can convert, or they can consider fractional order differential equation, and they can try to apply Picard's successive approximation method and fixed point theory, or rather Banach fixed point theorem, and they can study that equation. In addition to the above examples, here is the list of applications of fractional differential equations and some of the integral differential equations. So viscoelastic materials, polymeric materials, acoustic wave propagation in inhomogeneous porous material, fluid flow, dynamical processes with self-similar structures, dynamics of earthquakes, optics, geology, biosciences, medicine, electrical engineering, so element factors. Now see that for that electrical engineering, so I can try to work on fractional order PID controllers. So with the help of that fractional order derivatives, and we can try to find out some of the solutions. Still we are working on that. Next, economics, probability and statistics, astrophysics, chemical engineering, signal processing, chaotic dynamics, even fractional order models of love and emotions have been developed. So here mathematical applications to mathematical physics. So here example of Abel integral equation. So Abel was the first who used that fractional calculus to find out solution in 1823. So with the help of that, so he obtained the solution and he can use the fractional calculus in his solution. So that is the actual problem of Tatacoron problem. What is that Tatacoron problem? So this problem deals with determination of the shape of frictionless plane curved through the origin in a vertical plane along which a particle of mass m can fall in a time that is independent of the starting position. Another example is viscoelasticity. If I can apply that fractional calculus, then here we get that fractional differential equation in this form, and here if I can observe, so this is fractional differential equation. So another application in robotics and control theory. So more details on that robotics and control theory, one may refer that paper written by Silva and Machado. So here it is, put that paper by 11. Now, necessity of generalized fractional derivative operator. So there are a number of definitions of fractional integrals and fractional derivatives. And over time, new fractional derivatives and fractional integrals will arise. It is necessary to introduce a differentiable operator that unifies wide class of fractional derivative operators. So that is more general. Introducing a generalized derivative operator will overcome the number of definitions of fractional derivatives, and we can study the theory of fractional differential equations under one roof with generalized derivative operator. Particularly, so that psi for fractional derivative is more general derivative, so that choosing that value of that function psi and parameters a, b, it reduces to some particular definitions. So here in that next slide, I will quote that some of that derivatives. So here it is psi function psi, and here is the parameters alpha and beta. So here instead of that alpha and beta, here it is nu and mu. So if I can take that psi of t, and if I can take that value as 0, then that psi Hilford derivative reduces to RL derivative. So it is psi RL derivative. So if I can take parameter as 1, then it reduces to psi of t or psi capital derivative. If that parameter is 0 and function takes value t, then it reduces to RL derivative, that is Riemann-Livre derivative. If function is t and parameter is 1, then it reduces to capital derivative. And for function psi of t equals to t, it reduces to Hilford derivative. So in this way, if I can vary that function psi of t, and if I can vary that values of that parameter, then that psi Hilford derivative reduces to particular cases. The nature works with fractional derivatives. All systems need a fractional time derivative in the equation describing them. System have memory of all earlier events. So in this, necessary to include this record of earlier events to predict the future. So conclusion is obvious and unavoidable. Dead matter has memory. So for that more applications, so one may refer this book, so which is written by Shantanu Das, so Kindergarten of Fractional Calculus, or one may go with that book written by Kilbas. So here I can list some of the recent publications. So here is the list of references, and some references are added at the time or. Thank you. Over to you, Power.
Yes, sir. Participants, please ask your questions. Santosh sir. Hello, Santosh sir.
No question, sir.
Yes, any participant, please. If you have any type of query, please asked, somebody asked about what is mean by a particular integral. Kharat sir.
Hello. Particular integral is a solution of that differential equation which satisfies that given differential equation. So for more details, one may refer that book Engineering Mathematics 3 written by Kumbojkar.
Okay. Well, it seems to there is no question to anyone. Well,
Okay. At the conclusion,
yes.
I would say I have tried my level best to explain this concept. I thank all the participants who have actively attended and listened patiently. So once again, I would like to thank organizers for giving me an opportunity to interact with all of you. Thank you.
Sir,
Thank you, sir.
Sir. Kharat
Yes,
sir.
sir. Yes.
We got one question. Is there any restrictions for fractional type of equations?
Means any
No.
restrictions?
Mehta ma'am asked this question. Is there any restrictions for fractional type of equations?
I can't get that question.
Ma'am, will you ask by unmuting yourself? Is there any restrictions for fractional type of equation? Any? Ma'am, will you ask please? Just unmute yourself and please ask.
Any restriction in what sense?
Okay, she is not interested. Okay, let it be.
Okay, sir. Okay.
On the behalf of SKN Sinhagad College of Engineering, Pandharpur, I express my sincere gratitude towards Dr. Kharat sir for his nice presentation and valuable information on differential equation and their applications. Applications to real life problems and as well as applications in the research also. So that was very nice presentation. Once again, thank you, sir. Thank you.
Thank you, sir.
Okay, with this, I'm concluding today's day with this session. Thank you.